Hello Year 10, welcome to the second lesson of the topic B7. And I'm going to be honest, today is it's not the most exciting part of the topic. We're going to be talking about abiotic factors, and these are the non-living factors that affect a community. Okay, so we're going to talk through each of these in turn. It won't actually be a very long lesson, so that's one of the benefits of it, but we do have to get through these abiotic factors even if they're not that exciting. So here's our title: How do abiotic non-living factors affect a community? How do abiotic, which are the non-living factors, affect a community? Okay, let's move on to those factors. So abiotic factors include all of these 7 things, and we're going to talk about these in turn and write some notes on each one. So let's start with, and if you want to put it into a table you can, I don't think you need to, I think we'll just use subheadings. So we'll start with light intensity. Now we know a lot about light intensity from the topic before, where we looked at how light intensity affects the rate of photosynthesis. We understood that there's this optimum value at which we get the best photosynthesis for the least amount of light. We've got here a light meter, and this part here will detect the light and give a value. That can be in arbitrary units, it can be in lux, can be as a percentage. And we can find, looking at the light, by testing the light intensity in different areas and then looking at like leaf size, we can find links, and that can link to certain exam questions that we get, where we look at are they bigger leaves in a more shaded area to try and get maximum light. And some plants do actually like to be in the shade, so you know, we do see different plants in the shade to in the light. Okay, so that light intensity is a factor that will affect what plants are living in an area, probably not what animals are living in an area. So bearing all that in mind, you can just write light intensity and leave it there. You can write about the light meter, you can write about it being a limiting factor, having an optimum value, or you could write about the shade loving and the sun loving plants. Okay, let's move on to the second factor. If you need more time, you can pause now. So temperature. Again, we've got that optimum graph for temperature, where when particles gain more energy, they have more energy, more collisions, better reactions in the plant. Then we get to that optimum level, and then we get denaturing of enzymes after that. And different organisms can adapt for the different environments that they live in. So we've got the fur of the polar bear, the small surface area to volume ratio, and then we've got the lizard there, and we've seen the lizard, or we will see actually, we haven't come across it yet, but in a future lesson we're going to see a lizard dance where it lifts its feet to keep off the hot sand and then swaps them over. And here we've got a data logger with a temperature probe, and we've also got a thermometer, and we can see this is just referring really to precision of data and having a high resolution. We can see on the digital thermometer we've got 2 decimal places, so we've got a higher resolution and therefore more precise results. Okay, this one is only measuring to the nearest degree, this thermometer, and this thermometer, if it had an air bubble in it, would give us an inaccurate reading of the temperature. So trying to get those skill words in, because of the lesson we're doing precision and accuracy as well. So temperature will affect plants and animals, and we've got that bit there about the inaccurate thermometer if there's an air bubble, and also a more precise reading on this digital thermometer because it's got a higher resolution. Again, I'll allow you some time to write about that now. Just write some bullet point notes. Okay, moving on to the third factor. This one is moisture levels. Again, not very exciting name. It's called a moisture meter. And too much water in the ground can lead to flooding of a plant, and then there's no oxygen in the soil for it to take out for those root hair cells to respire. So that can be a problem. Too dry, and there's no water to take in at all. So when water escapes through the leaf by transpiration or evaporation, there's no water to be drawn up. And we can see here again, we get that optimum of the ideal water to be in a plant to get the best growth. Okay, you pause if you need to. Let's move on to the fourth factor. This one's a bit more tricky. So we've got pH meter, and the pH can link to what nutrients are available in the ground. So if we know that we're going to be growing a particular food, a particular vegetable on a field, and we know that that particular vegetable needs a particular nutrient, for example iron, we can see here that iron is highest in acidic soil. The farmer may actually make the soil more acidic to enable that iron to be present, and then it will have better success in growing that particular vegetable. So farmers can adjust the pH of the soil by putting chemicals on it to help the nutrient availability. Bit of a tricky one to understand there. So wide bars, where it's wide here, means that there's a lot of that particular nutrient present, and then there's obviously much less on these at this point here. Okay, pause if you need any more time. Point 5, so wind intensity and direction. You may well have seen something like this at primary school and gone out and looked at the wind intensity. We can see here that the wind is always coming from the same direction. Maybe it's like an exposed cliff, and so the plant has actually grown in this way, and that's great because it could provide some really good shade under here for animals, and you may find animals standing in that area. Also, the wind intensity will affect plants that maybe don't have very good root systems will be pulled out, and they won't be able to survive in that area. So intensity and direction have a big impact. Okay, pause if you need to. Point number 6, we looked at this one again in the topic B4 when we were looking at photosynthesis. Now this carbon dioxide is only really a factor where we've got a pondweed that's in the water, or we're looking in a greenhouse. If we're just looking outside, carbon dioxide levels don't change enough to have a big enough impact. But if we're in a greenhouse and that farmer's trying to maximise the rate of photosynthesis, then they may well pump some carbon dioxide into that enclosed space. Okay, we've got a carbon dioxide meter there that can be used in the water to see how much carbon dioxide is present in the water, for example, for the pondweed. Carbon dioxide not going to be a factor for animals. And if you need more time, pause now. And the final one is oxygen levels for aquatic animals. And this guide here, it looks a bit like the pH scale gone wrong. It's kind of all in the wrong order, but we've basically got low concentrations of oxygen and higher concentrations of oxygen, and the impact being what lives in that water. So this is aquatic animals only, so we're talking about in rivers and lakes. We've got our oxygen meter there, and if the oxygen levels go down, then we tend to find that anything with a nice name starts to die out. So we get like the freshwater shrimps die out, and the mayfly larvae and stuff like that. But in poor oxygen levels, we tend to get more sludge worms and rat tail maggots and things like that. So we've got some different ones here. Worms can cope in low concentrations of oxygens, but things like the summer flounder and the striped bass, they need high concentrations of oxygen. So that could be a situation where some sewage has gone into the water, and the bacteria have been feeding on that sewage and they're respiring aerobically, and then that is using up all of the oxygen, so there's less oxygen in the water, and therefore other fish and aquatic life don't get that oxygen. And if you need extra time on that, then pause the video now. So we talked a bit about precision. It's up to you how much you write. You could just go for the bold content. So precision, very little spread about the mean value. Think of precision as exactly. It's also linked to how many decimal places there are. That's why I put resolution on the same slide. So if we measure to a lot of decimal places, we have a high resolution. We have a more precise measurement. And more exact. Like if I said it's about 3 miles to town, and then someone uses their car to measure it, and they say, well, actually it's 3.25 miles to town. They're using a higher resolution, therefore they're being more precise, more exact. Okay, pause if you need to. Collecting accurate data close to the true value. This is about our scales being on 0. I talked about the air bubble in the thermometer. So it's about having equipment that is giving a value that is what it should be. So if I jump on the scales at home to weigh myself, and the arrow isn't on the point, on 0 to start, then obviously it's going to give me an inaccurate reading. Pause if you need to. Repeatable, reproducible and reliable. We used to just say that if we did an experiment lots of times and got similar results, that made our data reliable. And now that's been broken down into 2 separate words. Repeatable is if I continue to repeat the experiment several times and I get similar results each time, then I can say that my data is repeatable. If I give my experiment to somebody else and they complete a similar or the same experiment and they too get similar results to me, then we can say that those results are reproducible. Somebody else has reproduced our method and got similar results, but the results have got to be similar. It's not a case of just saying, oh, well, I've repeated it and I got 3 different sets of results. You can't say it's reproducible or repeatable. Okay, but both repeatable and reproducible go under that heading of reliable. If you need to pause, do so now. Random error. This is about just results varying in an unpredictable way. If I timed how long it would take for 100 mils of 20 degrees C water to boil, then every time I do that experiment, I'm going to get a slightly different answer, and that's just random error. Okay, and I can fix that by trying to measure the volume of water as accurately as I can, trying to make sure that the starting temperature is as close to the same every single time. And that's why we do our repeats and then we calculate a mean. If you need to pause, do so now. Systematic error, where the readings differ from the true value by consistent amounts. So it's always giving a wrong answer by, say, 0.5, okay? And that could be that there is an external factor that is, say, go back to our boiling water, because the water is being heated, but some of the heat from the flame is going to the atmosphere, then systematically we're losing the same amount of heat to the atmosphere. So that would be a systematic error. Okay, pause if you need to. Okay, so we can match all of these up. That's an activity that you could do if you want to. And if you want to do that activity, then please pause now. So here are the results of that match-up activity all matched up. If you would like to write those out, it might be a good way of doing it. If you've already written some notes, then don't feel that you have to. And that takes us to the end of this lesson on abiotic factors. Like I said, not the most exciting content to learn, but hopefully you've learnt what they are. Next lesson, we're going to be looking at the biotic factors. There's only 4 of those, so it'll be a nice short lesson as well, which will work nicely to tie in with the educate that I have set for you for that next lesson. So next lesson, third lesson, we're going to do another video. We've got 5 educate questions, and if you need to do the drop-in teams, you'll be able to do that next lesson. Thank you very much. Bye.